Now this is one of those questions where once again you need to use a picturization skill. You need to be able to visualize it properly and jot down all the information to get the answer. So what I'm going to do is I'm going to draw a really big diagram here, as big as possible, and show you how to solve this. Now once again, this is the origin, this is x, this is y. We are given that ABC is a right angle triangle, right angle at B, so this is 90 degree. Okay. We are also told that BAC is 30, so this is 30. If this is 30, then obviously this has to be 60 degrees. Okay. We also know that this is 3, 4. And this C is 7, 4. Okay. And we need to find out the coordinate of y coordinate of B. So we need to find out whatever Vx does not matter, but we are focusing on y. What is y? How much is y? Now, understand that y is actually the perpendicular distance, right? If I drop a perpendicular on, one thing important thing that you'll notice here is that this line AC, we are getting 3, 4, 7, 4, right? And you notice that the y coordinate is the same. It's 4, which means that AC is actually parallel to the x-axis here, because it's a straight line and it's parallel, and because it's not a crooked line. The y is the same for both of them. So if I drop a perpendicular to find out the perpendicular height, if I drop a perpendicular here, I'm looking at this height here, this whole thing. Okay. Now if I'm looking at this whole thing, if I'm dropping a perpendicular, even this will be perpendicular, and that is the reason for me telling you that these are parallel, because they are AC is in the straight line. Okay. Now when I straight line, don't take me wrong. Please understand when I say straight line, if I had a line something like this, 3, 4, and say 3, 3, 4, and say 7, anything, say 6. Now it's this line is like this. Okay, it's moving up. It is not going in the same straight line. It should, a line that goes straight line like this will have, we need to do something like this. Okay. So hope you understand that you're looking for a line which will be parallel, and they'll be parallel when the y coordinate is the same. In this case, the y coordinate is the same. Okay. So the idea here is that we already know that this perpendicular height is 4 here. Okay. So our focus would be just to find out this height. How much is this? If we can find out this height here, 90 degree height here, that would be sufficient to get our answer. So how do we do that? How do we find out the height? For that, once you make these inferences in this diagram, understand after that all you need to do is apply the 30, 60, 90 property to find out your answer. And let me show you how. So I'll just draw the triangle here, because that is all you need now. This is 90, this is 30, this is 60. Notice that you know this length also, AC. If this is 3, 4, that means this part is 3 and this whole part is 7, right? So if this whole part is 7, then this remaining part out here would be 7 minus 3, which is 4. So I can say AC is 4. Okay. If AC is 4 and it is opposite 90 degree and it's a 30, 60, 90 triangle, we can find out the length of AB and BC. So we know this is side opposite 30. So we can say that this is BC is to AB, which is opposite 60, is to AC, is in the ratio 1 is to root 3 is to 2. We already know AC is 4, so we can say 4 by 2 must be equal to AB by root 3. So AB would come out to be 2 root 3. Okay. And AC would be 4 by 2 is equal to you have BC by 1. Okay. So BC would turn out to be just 2. Now you might be wondering, why am I doing this? And how is this going to help me find out this height here? Well, we need to take advantage of the 90 degree that we have in the triangle. So if ABC is a right angle triangle, then we can find out the triangle. Now here's how you need to write it. We can find out the area of the triangle by saying it is equal to half AB into BC, right? Because this is 90 degrees, so this will turn out to be, say, the base, and this will be the height. Okay, but notice we can find out the area of the triangle by also taking this as the base and this as the height, and the area has to be the same, right? So we can say whatever be the perpendicular, let's take this as BK. We can say the area can also be written as half into base is AC into B of K. And we can equate both of them. We can cancel out half. We can say that AB into BC is equal to AC into BK. We know AB is 2 root 3. We know BC is 2. We can see AC is 4, and we need to find out the height BK. From here we can cancel out 4, and we can very clearly see that the BK is nothing but root 3. So this perpendicular height is root 3. So I hope it's perfectly clear how we did this. The first thing that we did was we took advantage, we understood the fact that we need to find the perpendicular height, and we already know 4, so we need to find out this perpendicular. And we were able to do this because we could see that AC, the y coordinate is the same, so that means this line is moving parallel to the x-axis, and that is why these will be 90 degree. So if this height is 4, we just need to find out the other perpendicular height. Once we made this inference, all we did was we used the 30, 60, 90 property to find out the lengths AB and BC, which we found as 2 root 3 and 3. Once we had this, we know that in a right angle triangle we can find out the area by doing half AB into BC, and we can also find out the area by using this perpendicular in this space and equate it. And from here we got the value of BK as root 3. So the total height is nothing but 4 plus root 3, and hence the correct answer in this case will be option D.